Welcome everyone. In this video I'm going to show you a modification to my LinkMicro digital microscope. So this is the microscope. I have shown this earlier in an introduction and review video. Please check it if you are interested in more details. But in this video I'm going to concentrate more on these things which are related to this modification. But before talking about the modification, I just want to tell you why I want to modify this microscope and what is exactly which part I'm going to modify. So the reason why I put this on its side is because, first of all, I cannot fit everything under the camera, but more importantly, everything is on this side, and it just makes more sense to record it this way. So what we have here is that this rod here is the Z column or Z axis, and the wall camera basically can be slided up or down along this rod. And here there is a stop screw which I can move up and down, and then with this set screw I can stop this, not the screw but the collar. And then this part, if I rotate it this side, has another stop screw here, and then as you can see I can move this shaft up and down. So now I remove this, and then we can focus more on this part. So what this part has is that it has this thing. So in this hole we have the Z column, but then we can move the camera in or out. So then if you look at the base plate here, then let's say when this is like now fully pressed in, the camera focuses at this point, but when I pull this out, then the camera is brought further out, so the camera might focus here. So if I have my subject here or here or here, I can make the camera focus on the subject, and it will be in the center of the display. So this is a nice thing, but I will actually remove this because I will have fixed subjects right here, so everything will be adjusted to that. But then what else is available here is this mechanism here, and we have a stop screw here, and if I unscrew it a bit, then you can see that this thing goes up and down. So this is kind of fine focus stuff, but I don't really understand its purpose because we have a focusing ring on this. And actually I can have basically the same kind of range with the focusing as I can have with this fine Z adjustment screw. So I just don't understand. Maybe the makers had a purpose for this. I just don't know what it is. But I will actually keep this. I will only remove this rod. But why I modify this is a bit more interesting in my opinion. So if you look back at the base plate, we can see that there is some hinge here. And in my case, and I showed this already in my introduction video, that this moves. And I try to tighten this screw or bolt, but I could not make it tight. So I always had this problem. So my Z-axis was basically wobbly. So then, yeah, you can see that it moves a lot. What I'm going to do is that I'm going to replace the Z-axis, and I will make it super solid. And I also make it adjustable with the help of this guy here, which is a lead screw. This is a simple T8 lead screw, 2mm pitch, but 4 starts. So actually the, let's say, real or effective pitch of this is 8mm. So if I take this here, it's the simply it is the breast nut, and if I do one full rotation of this, then actually the linear travel of the nut is 8mm. So if I keep this like here, then actually, yeah, you can see now it slides down. Each rotation of the shaft will move this thing up or down by 8 millimeters. So I don't have to rotate it too much to make a significant movement along the z-axis. And then another thing we have, it's the same length as the lead screw here, is just two, let's say, shafts or rods, and they are just support rods, and I will mount these two bearing blocks on them, so they will slide up and down. And then what we have here is the most important part. Basically, you can guess that this breast nut will actually sit in this hole here, and then on each side I will have the bearing blocks, something like this. And then here on the side you can see we have 4 bolts or 4 screws or screw holes, because the camera goes there. We have the 4 holes there, so I will remove this rod together with this S-shaped thing, and then basically this side will be revealed, and this whole block will be revealed, and it will sit in this, yeah, let's call it seat. Very nicely it will fit in this. And then as I remove this thing, it has these bolts here. There will be one 3D printed block sitting there, and then the rods go into the 2 sides, and then we will have a bearing block here that will sit in the center, and this lead screw will sit in that bearing block. I put everything together, and then finally I will close the whole thing from the top with this almost identical end piece. And then I also printed this wheel, which will be mounted on this screw, lead screw. And then here is a hole. I have a bolt which will go through here, so I can use it as a hand wheel. But I will show it step by step how it works. So now what I'm going to do is that I'm going to assemble this thing. So I will remove this stuff, and then I will step by step install everything. So those are the 2 holes which are revealed there, and here we have the back side. And of course I have already disassembled this to measure the holes and the distances. So then I made this part, and this is the top side, and this is the bottom side. So this will basically just sit here, and hopefully you can see that the holes are nicely centered and everything. So I will just put nuts in each holes, and then from the other side I will screw in some bolts. Or I can do the other way around, because the nuts sit here very nicely. So the block is installed. As you can see, the screws are not sticking out too much, so that is nice. And then what happens here is that we can install the bearing here. And I will just simply screw the bolts into the plastic. It's not really moving anyways, so it doesn't need any strong support here. So this just goes on the top, and I just screw on it. So it's there, and it's solid enough. So now I just screw out the set screws a bit, so I can put in the lead screw. So that's good enough, I think. Let's test it. So it's good, it goes in. So before assembling this part, I assembled a crosshead, and start with this. So this goes in. And now comes the more difficult part, to install these blocks. Why it is difficult is that it's a bit cumbersome to access the screw holes, but it's not impossible. It's just a matter of patience. So I will just loosely connect the screws there, and then once all of them are in, I will tighten them with a tool. So the crosshead is assembled. I will not install the camera yet, because it's easier to assemble these things first. So let me see what I can do here. So just at an arbitrary position I install this, and then I try to install this. So now this is how it looks from the front side. Almost everything installed, and yeah, basically we just need this, but before putting this on I obviously need the bearings, so let me install that first. So to make it a little bit more rigid, I will drop a few drops of glue inside. I just seal it by halfway pressing this, so the glue won't flow out downwards. And then I just take some super glue and drop it on the wall. Just a few drops. Nothing extraordinary. And we close it down. And then clean up the leftover. Doesn't have to be perfect. And our Z-axis is done. I just need to tighten the screws here and there because they got loose due to the hammering. And now comes a bit more fun part. So what we have here is that I have this hand wheel, but you can see that hole right there, and I want to drop this there. Obviously I want to heat this up, so I will have to be careful with the soldering iron, because then I want to have some stop screws which can help me to fix this firmly on the lead screw. So maybe I will switch camera angle and then I will show you how I struggle with this. So this was kind of a failure, because as you can see the plastic went in and that is not so good. And the alignment also kind of bad, but there is another hole. So what I did, I put in a bolt there, and you can see that it's almost through the wall center piece. So then I will just screw this against the lead screw, and hopefully one contact point will be enough. So let's see. So this seems to be sufficient, but there is one more thing that I need to install, and that is this, which is our handle. So now there's a cute little handle there, so I can grab this and handle it, turn it. So this is good enough, and just to show you, it turns nicely. So let's put the camera on this thing. So first of all, I will remove this thing. So I have to unscrew these 4 screws. So now this came off, and we are left with this thing. So the 4 holes are there, and of course the crosshead is carefully designed. So this should fit, but there's also a chance that it doesn't. So let's see. So far so good. So this part is done. So it's fixed. And as you can see, hopefully you can see, that now this silver colored column is sitting in a seat, and it's supported and fixed by 4 screws from with this side. So that is like enough, I think. There is no support on this side, but yeah, it's in a seat, so it should be fine. So then the camera is sitting there, and I can just turn this basically very effortlessly and move the microscope up and down. I will change the camera angle just so you can see this from side view. So here is the thing. Here how it looks from behind. So crosshead, 2 bearings, and then the lead screw here, the 2 support columns, top end piece and the bottom end piece, and then the bearings for supporting the lead screws. And then this is the side view. So you can see that the camera sits there, and then the camera is actually looking at roughly this point, which is good for me. And then if I turn this thing, you can see that it goes very smoothly. I mean, now I just have my index finger on it. Let me show you. So it's really, I just put my index finger there, and it goes up and down very easily, even upwards. It's just index finger. Actually, the glove gets stuck in the threads, so that's why I'm struggling. But yeah, you can see, and it goes all the way up. And there's a funny coincidence. I bring this closer, and I zoom in. Now you can see that we hit the end piece here with the bearing, but actually this stop screw, if you hear it, hits this handle as well. So it's really calculated, but no, it's just a coincidence. But you can see it works. You can go down very easy. And now of course it's a bit wobbly, but it's not wobbly when it stands still. It's only wobbly when I'm turning this thing. So maybe just for fun, since I have the memory card in this already, I power up the microscope, I put some subject under it, and we look at it, how it works through the camera. So how it looks through the camera when I move this wall thing, and how stable it is when I don't move it. And then we can evaluate it. But yeah, before that, basically this is the project. For some more details, more pictures and stuff, please visit my website. I put a lot of description, some discussion and stuff on my website. So if you want to understand more about this project, you can understand it. And also what is more important is that I shared these 3D printable files. So if you feel like doing the same modification to the same microscope, then yeah, you can copy these files, print it. Or you can, for example, use PCB-based printing services, but this is just, I mention it, it's not a sponsored part. But also I shared all the parts, the relevant parts, so you can also support me with that. And if you want to further support me, you can visit my Patreon, and then you can just sign up to any kind of tiers if you feel like. But yeah, let's switch to the microscope camera and look at some stuff and see how the camera behaves. Okay, so this is what we see right now, and then these are just the pads of some printed circuit board for an IC. And you can see sometimes that if I hit the table, then there's some vibration, but that would happen with the other column as well. And now I will basically turn this thing, and you can see that it moves out of focus, and this is basically the vibration that you can see. And now I'm turning the focusing ring carefully, just to reveal more. So obviously now I move the microscope upwards, so I increase the working distance, so the distance between the end of the lens and the surface of the subject. So then together with that, the field of view also increased, so we can see more now. And you can see that, yeah, it's stable enough, and I can go higher up. So I go to the max, just to hit the top. Somewhere here. And now basically this is what we have. So now I'm actually measuring the working distance, and this is actually just around 18, 19 centimeters. I cannot put the ruler close enough to measure it precisely, so yeah, let's say 18 plus minus 1 centimeter. And I could go even higher up with the lens that I have on the microscope, because the object distance or working distance on this thing is 300 millimeters. But actually, if I compare the height of this thing with the original Z column, I could not go higher on the Z column either, or maybe just 1 centimeter, which would not make the object distance to 300 millimeters anyway. So basically we kept the same range that we had earlier. But yeah, for my soldering videos and stuff, I think this will be just enough object distance. And anyway, I have another lens, so that might provide a bit more range or field of view anyway. So now you cannot see anything, but I changed the lens. So let's try to focus. And this is the other lens, and I can comfortably fit the wall PCB under it. So that's for me is enough. And if I go down, then of course it goes out of focus. But then I focus again, And there we have it. So I think with this other lens I will be more than fine. We can see all the details, we can see the tip of my tweezer and so on and so on. So I'm satisfied with this project. So I will stop the video here. It was long enough anyway. So I hope you like this modification to this microscope and hope that LinkMicro also likes it. But nevertheless, it's an interesting project, and I think for myself or my application, I improved the microscope. So yeah, if you feel like repeating my modification, go to my website. You will find all the resources there. And if you think that my work worth a bit more support, then please consider supporting me on Patreon. So I hope this video was useful to you. I hope you learned something, and see you in the next video.